as long as I can show that the sequence is monotonically increasing or decreasing, then if I can show the sequence is bounded, then it has to be convergent. So here's what I'm going to do. I'm going to try and see if the difference between the next member, that's a sub n plus 1 minus an, right? See if it's greater than 0 or less than 0. So that is equal to, first of all, let's notice that the only difference between an plus 1 and an is that, first of all, they both have 1 over square root of 1 plus 1 over square root of 2 plus all the way up to 1 square root of n. And this guy has just one more term, 1 over square root of n plus 1. And the difference is that here I have minus twice of square root of n plus 1 for this guy. And for that guy, I have minus 2 times square root of just n. Right? So if I take their difference, I should have exactly minus 2 times square root of n plus 1. And minus minus becomes plus, twice of square root of n. And remember, 1 over square root of 1 all the way up to 1 square root of n just cancel out, right? I'm only left with the last item, that is just plus 1 over square root of n plus 1. Right? So I'm going to take out the 2. And what I have is 2 times square root of n minus square root of n plus 1 plus 1 over square root of n plus 1. So I'm going to rationalize the numerator. I'm going to multiply both the top and bottom by square root of n plus square root of n plus 1. So what do I have? 2 times bottom, I have square root of n plus square root of n plus 1. On the top, I have just square this and square that, take their difference. I have minus 1. Right? And plus 1 over square root of n plus 1. Right? This time, I just take the common denominator. That is just square root of n plus 1 times square root of n plus square root of n plus 1. Right? What do I have on top? Square root of n plus minus twice of square root of n plus 1. Right? I have exactly square root of n minus square root of n plus 1. Right? So the bottom is clearly positive. The top is negative because n is smaller than n plus 1, right? So the square root of n is smaller than the square root of n plus 1. So the whole thing is negative. So which means an plus 1 is in fact smaller than an, which means the sequence itself is decreasing. Right? Monotonically decreasing. Now, if I can show that, the sequence is bounded below, then I can show the sequence is convergent, right? So a natural thought is to use the definite integral to estimate the value of this sum. Right? It's a very natural thought. So I'm going to construct the function f of x. Just replace n with x. Right? I have 1 over square root of x. So I'm going to just draw a graph. Right. X, y. So generally speaking, first of all, the function is obviously decreasing, monotonically decreasing from 0 all the way up to positive infinity. Then I'm going to divide the 1, 2, 3, 4. Generally speaking, if I have, so here's the graph. Right. So generally speaking, if I have an integer, right, k and k plus 1, right, here's k, there's k plus 1. In this small interval, I should have exactly the estimation of the area. So the area under this curve should exactly be greater than the area of just this rectangle, right? However, it should be at the same time smaller than the rectangle that's just this one, right? This rectangle. Right, so for example, in this interval, the area under the curve should be a little bit bigger than the area of this rectangle. At the same time, a little bit smaller than the area of this rectangle. Right, from the graph, it's obvious. So, generally speaking, from k to k plus 1, the area under the curve, what is that? That is simply the integral from k all the way up to k plus 1 of f of x dx. First of all, it is a little bit bigger than this smaller rectangle, right? What's its area? Right? So the bottom length is just 1, right? Its height, what is height? Height is the functional value when you plug in the right-hand side edge into the function, right? Represents its height. Yes. So let me just plug in k plus 1 into the function. That is 1 over square root of k plus 1. And less than, for the same reason, the bigger rectangle, what's its area? Its bottom length is just 1. 1 times the height is when I plug in the left-hand side edge into the function, right? That is 1 over square root of k. So k should go from, let me see, should probably go from 1, right? Because 0, it makes no sense. So let me just go from 1. 1, 2, 3, 4, all the way up to, let's say, perhaps n, right, perhaps, or n minus 1, whatever. So let's just take the sum on both sides, right? The sum, first of all, the sum, perhaps k goes from just 1 all the way up to, you see, maybe just n plus 1. Perhaps n, right? So less than sigma k from 1 to n, integral from k to k plus 1, f of x dx, less than sigma k from 1 to n, 1 over square root of k. So 1 over square root of k plus 1. Right? So in this case, since it's only a finite sum, right? Then I can, so basically what the middle means is just the integral, first of all, from 1 up to 2, then plus the integral from 2 to 3, plus the integral from 3 to 4. Right? So basically it's just the integral from 1 all the way up to n plus 1, right? So integral from, what's the integral from, what's its antiderivative? What's its antiderivative, that is? Let me just see, twice of, so twice of square root of x, is it? Half times, yes, that's its antiderivative. So I'm going to evaluate from, like I said, from 1 all the way up to, the last one is n plus 1. So from 1 up to n plus 1, right? So that is less than sigma from 1 to n, 1 over square root of k, bigger than the sigma, 1 to n 1 over square root of k plus 1, right? Then what's the middle? So I should have square root of twice. So twice of square root of n plus 1 minus 2, right? So twice of yes, that is less than sigma from 1 to n 1 over square root of k. It's bigger than sum from 1 to n of 1 over square root of k plus 1, right? So basically, I just need to minus twice of square root of n on this side, right, to achieve the sequence an on both sides, right? So in other words, this time an should be greater than minus twice of square root of n plus 1 minus twice of square root of n minus 2, right? So again, to further estimate an, we just estimated this part, right? So we can just simply replace n plus 1 with just n to make it smaller, right? So that is bigger than twice of square root of n minus twice of square root of n minus 2. And that is simply just 2, minus 2. Right? So, which means an is really bounded below. Right? So, first of all, it's monotonically decreasing and it's bounded below, therefore an has to be convergent. Right? For the same reason, I'm just going to skip over the details. Bn is also convergent.